So howdy guys, today we're going to be talking about integrals. So hopefully by now, we know that if you want to take the derivative of x cubed, we can get 3x squared pretty easily. We subtract 1 to the 3 to get the 2, and we bring the 3 down originally to get 3x squared. And that's all well and good, but what happens if we want to do the opposite? What happens if we want to come from 3x squared all the way to x cubed? Well, that, my friends, is called the antiderivative, right? So let's dive a little deeper into that. So x cubed, the derivative of x cubed is 3x squared, right? But what about the antiderivative? The antiderivative of 3x squared is x cubed plus c, where c is just a constant, which is a fancy word for just a number, right? And that's going to be our general solution. Now, you may be wondering, where the heck is the c? Like, why do we need that there? And for that, let's look at a few examples. So remember that the antiderivative is just the opposite of a derivative. We have the derivative, but we want to get back to the original function, right? So let's see. The derivative of x cubed is 3x squared. Yes, we've already established this. Okay, but what about the derivative of x cubed plus 4? Well, of course, we know that when we take the derivative of a constant, that just drops. So again, that's 3x squared. Okay, what about the derivative of d to the x cubed plus 17? Well, that again is going to be 3x squared. So we see that there are many different antiderivative answers for 3x squared, because many different functions is going to give us the same derivative, right? So in order to encompass all that, we just add a simple constant, right? Right here. So c is just going to represent a constant, right? And for us, that can be a 4, a 17, a 27, 132. It doesn't matter. And you shouldn't really be too concerned over it. Just when you see C, I know it can look a bit confusing, but just say it's just a number, and you can even switch it to a 5 if you so wish. So let's take a little look at an example, right? So we know that the antiderivative of 3x squared is x cubed plus c, right? So what if I want to take the antiderivative of this function right here, this y prime, which is 2? Well, for that, we have to wonder what derivative is going to give us 2. And hopefully at this point, we should be able to pick up that if we just add a simple x, right, that will give us the antiderivative, because 2x with just one x it's just going to be dropped, right? We know if there's just one variable to the power of 1, we just drop it, right? But again, we're not done here, right? Because also what we can put into this little box right here is 2x plus 1, 2x plus 17. Perhaps we can put 2x minus 107. Right? These are all viable solutions. So it's very important to add a plus c in there. And this plus c is just a number. It's a constant, right? So that is going to be your solution. Y equals 2x plus c. So 2x plus c is the antiderivative of 2. Wonderful. So let's look a little bit closer into the notation, right? So here in this notation, we have y prime equals f of x, right? So let's just say that this derivative is just equal to f of x. How do we get to the antiderivative? Well, for that, we're just going to use this like little fancy notation, right? So if y right here is the derivative, right? Then y, to get there, we're just going to use this little fancy symbol called an integral. It just looks like a really long S, right? And then we're going to have d of x. And this d of x, like whatever is after the d, so in this case x, is going to tell us what we're integrating by. So what variable we actually care about. But we'll see that in future lessons, right? F of x, this is called the integrand. It's what we're actually integrating, right? F of x, in capital F of x is going to be the antiderivative of f of x. And that's kind of typical. We use capital letters to denote the antiderivative. And then C is going to be the constant of integration. Now, the only terms that I've really seen used commonly is constant, is antiderivative. So if you're caring for a test, just memorize those, and I think you'll be fine, right? It's important to remember that like d of x and like this little like s symbol, the integral symbol, are opposites. So it's much like plus or minus or like multiplication and division. These two things are opposite of each other. So don't get too caught up in it. Of course, we'll have more examples in future videos, but I hope integrals are a little clearer today for you. Have a great day.